So another update on the XY table project for the microscope, and this is my 3D printed test setup for the table that uses the reused DVD or CD drive motors here. And as you can see, it doesn't have much torque, so it jams occasionally, and I've had to jury rig up a connector for the thread. Now on eBay I saw that there was a listing for this, and you can see that it's much smaller, and this is a micro-stepping 2-axis stage. I don't know what the original use for it was, but you can see it's a lot smaller than my 3D printed arrangement. It doesn't have as much travel. You can see that we've got only a few millimeters in each direction, but it is a micro-stepping stage. Now I think maybe that size would be sufficient for a small die, so I think we're almost there in that respect. But what's interesting about this is that the mechanical arrangement isn't actually coupled to the screw. There's a lead nut, I suppose, that rides on the thread of the stepper motor, and that just pushes this stage against a spring, and it's running on two, is it two? It's running on two straight bars, or is it one bar? I think it's running on two. So you end up with one motor pushing here and the other motor pushing here, and it's just the mechanical arrangement means that you can move in either direction. So it's not the same as this mechanical arrangement where I've got one table on top of the other. It's actually one mechanical stage, I suppose, that can move in both directions, and that means the motors are in the same plane, and that means it's very thin. I mean, that's only, well, it's less than 10 millimeters, I should say. Let's have a look and see if I can work out. What is it? Yep, that's about 9 millimeters, 8.5, 9. So that is very thin, and that would be very useful, and the whole size would fit easily under the microscope. So one downside to it is it's got this flexi connector, which is a bit of a pain. I think I'll just desolder that and take it off, because trying to sort out these connectors on the end is just pain. What it does have though is here and here, it's actually got an opto sensor which can sense the position of that part of the table or that part. So you've actually got feedback of where the stage is, which is interesting. I don't know what this was used for, but that could come in handy. Let's have a look and see what the actual travel is. I think we'd probably be able to go from there to there, which is not a lot. Can we measure that? Yeah, so that is 2.5 millimeters. So that's not much. But what I'm thinking is I'll probably make up an XY table using this and just attach it to the drivers and so on and see how it works, and then maybe using the other motors that I bought, which have a travel of, I think it's more like 20 millimeters, use the same mechanical arrangement and see if I can recreate with a 3D printed setup the same mechanical arrangement they've got here. I don't know what I'm going to do about the position sensors. It'd be nice to have them, but it's extra complexity, and as long as you don't lose steps, I'm not sure that that's going to be hugely useful. Okay, so there are two bars. There's a straight bar there and another one here. So there are two. So that is running on two straight bars, and presumably the other side is also it's also running on two. There's one there, millimeters, maybe, I'm not sure. So yeah, so we'll see whether I can get it working in this setup in place of my extremely large, I mean that looks huge now, table. So I've got the stepper drivers attached to this and it does work. So you can see there I've got one of the motors driving backwards and forwards. It's not driving far enough, and at the moment with the code I got on the Arduino I've only got it, I don't think, well it's definitely driving one part of the stage, but the other axis I don't think it's actually touching the pin that this white nut engages with, so it's not actually moving the other axis, but I can drive them, so that's good. I think I can see why they've put the position sensors in there, because it's so small it's very difficult to work out whether you're engaged with the stage, whether the nut is actually driving anything. So I'm going to investigate those and see whether there's an easy way I can get feedback of the position. That would be useful. So I've got the small table doing a scan. It's still not perfect, but you can see that it moves to the side there and then scans up and down, and that's just using roughly the same firmware that I had driving my large table. So it looks like this is sort of suitable for smaller dies. I think the movement you're actually going to get out of it is probably only going to be a couple of millimeters in each direction, but that's still sort of okay. I've had a look at the mechanism and I think it can be scaled up to something more like 10 millimeters by 10 millimeters, which would, I think that would easily cover any of the dies that I've got. I don't know if I can 3D print something that small. Maybe if it's scaled up to 10 millimeters by 10 millimeters I would be able to. It's fairly smooth movement as well. I think there's an 18-degree step on the motors, and as the lead screw's got quite a fine pitch, I think that's going to be okay. That doesn't really matter actually. I mean, I'm not looking for smooth movement, I just need to step by a sort of fine-ish distance just to get the die shots lined up. So yeah, I think this might work. It seems to be a better mechanical arrangement than my rather simplistic table on top of a table. It does require a slot in one of the tabs that's driven by the motor, because that needs to move in the other direction as well as the one that the motor's driving it in. But I think that's doable. So it'd be interesting taking the motors I got with a longer lead screw and trying to put those into a 3D printed mechanism which works in the same way as this one. So I've got the small table here scanning. You can see it's scanning in this direction here, and the stage is moving up and down. This one here will step across, but there's a bit of slack before the nut hits the tab that drives it in that direction. It's all spring loaded, so you can move it, and the motors just stall at either end, so that doesn't damage the lead nuts as far as I can tell. So there you go, there's a slight movement there in that direction. I'll probably leave that running and do a bit of a time lapse on it.